transportation and construction industries. From off-road powerhouses to traveling condominiums. They are rigorously tested and built to last. Now, trucks on Modern Marvels. When the going gets tough, count on the world's arsenal of wheeled workhorses to muscle in and meet the challenge. No matter how dirty or daunting the task, trucks ride to our rescue. From transporting our most dangerous cargoes, to carrying military and emergency teams, to supporting the mightiest civil engineering feats. But first and foremost, we rely on trucks to deliver. A network of multi-ton vehicles transporting goods and raw materials between producer and consumer is the economic lifeblood of the nation. More than 80% of all freight in the United States moves by truck.
You know, as the economy grows, one of the things that takes off in parallel is truck driving. Because this is the way that most goods are transported across the United States. In fact, pretty much anything you can think of has been brought to you at some point by a truck.
America's love affair with trucks is more than a century old, but still going strong. Trucks not only symbolize the romance of the open road, but also thunder along as the very epitome of power and endurance. One recognizable phrase sums it up: built like a Mack truck. Mack Trucks, now owned by Volvo North America, conjures images of ironclad strength and unwavering dependability. Volvo operates 2 test centers where researchers and engineers are helping to ensure that Mack maintains its rugged reputation.
A truck customer expects a tremendous amount, and they should. In 1 year's time, a heavy-duty truck can run twice as many miles as your average car or pickup trucks will in an overall lifetime.
Engineers at the test centers stress and load individual components to make sure they won't fail in the real world.
With the accelerometers, we gather direct information for calculating force on the components and the systems within the truck. And we have strain gauges so that we can measure direct strain off the components and to be able to do stress analysis on these pieces. The cabling, as you see down the vehicle, will run into a data recording equipment so that we can take the real-time data later and extrapolate it and to be able to convert that electrical signal into direct measurements.
Some of the machines seem more torture device than engineering equipment.
The cab bump test rig is used to evaluate the durability of a cab under severe impact type of loads. This is particularly important for vocational type of trucks. As they operate off roads, you go through potholes, you go over rocks, bumps, various types of uneven terrain.
Once the lab tests are completed, the trucks pit their strength against a half-mile gauntlet where only the strong survive. The object is to see how well and how long they can withstand the worst road environment possible.
On the endurance test, each truck that we have is tested for 12 weeks, roughly, which simulates 1 million kilometers of actual road miles. We run the test 24/7 until the test is completed.
Now we're going to do a high-speed lap at 24 miles an hour, run over the corrugations, and that's basically check the front suspension. I can tell when something's not right. Hear something, bad noise like a brake in the suspension or something, and I stop and check my vehicle to see what it was.
Lessons learned at the test facilities ensure that today's Mack trucks live up to the reputation of their predecessors, which first rolled off the assembly line in 1905. Mack draws on decades of experience to build trucks for every application.
Truck manufacturing is similar to automotive in that we have assembly lines, and that's where it ends. Henry Ford would roll over in his grave if he saw what was coming down our lines.
Yesteryear's auto pioneers would also be bowled over to see robots on the line, working side by side with workers to get dozens of trucks off the line every day. The Mack plant, the Makunji facility just outside Allentown, Pennsylvania, sprawls over 1 million square feet. Enough floor space to house 4 aircraft carriers. The plant runs 3 cab lines, 2 chassis lines, and a paint facility.
What we're looking at now is a frame. This is the bare bones truck right before anything really major happens to it. What the frame is made up of, major components of the frame rails, cross members, and then you have your front and rear axle assemblies. Once these hit the line, we can do anything with these, and the truck can be 100 different variations on any set of rails like this.
From these rails, workers can create vehicles ranging from garbage trucks to dumpers to mixers. The one thing they'll all have in common is a huge diesel engine. Some can produce an astonishing 600 horsepower. That's twice as much as that produced by an average pickup truck. These engines weigh in at a hefty 3,000 pounds. And even for experienced assembly line workers, placing them onto the frame is a difficult procedure. In another part of the factory, workers assemble the truck's cab. After welders make the initial welds, their robotic counterparts finish the job, doing the repetitive work of welding the cab's parts together. Once complete, the cab is hoisted over the frame and bolted into place. And the familiar form of the truck begins to take shape.
Right now we're at the end of our H line in Makunji. On this line daily, we have about 27 trucks come offline. They come off about every 15 minutes. Across our second chassis assembly line, we run that at about 39 a day, and they'll come off every 9 minutes. So our overall rate between the 2 lines is 66 trucks a day.
The final product can average between $60,000 and $130,000 without the body. Once finished, the truck is ready to handle whatever the customer can dish out. But the strength and dependability of modern trucks is as much a story of evolution as of nuts and bolts.
As far as the first truck in the world, there's some question about when that actually occurred. I think a lot has to do with what is the definition of a truck. There are records that indicate a French artillery captain by the name of Cuneau developed a steam-powered tractor used to hold heavy military cannons in 1769.
Other large steam tractor engines would emerge and be used to pull buggies and wagons. But these early vehicles were inefficient and soon became novelties used by the wealthy. By the middle of the 19th century, the horse was still the most efficient form of road transportation. But that would change with the advent of the internal combustion engine by N.A. Otto in 1876. Over the next few years, tinkerers and craftsmen from around the world embraced these new engines. Then in 1892, Charles Duryea built what many believed to be America's first gasoline-powered vehicle. 6 years later, the Winton Motor Carriage Company of Cleveland claimed to build the first commercial gasoline delivery wagon, which was an accurate description. By the turn of the century, most truck bodies were little more than modified wagons. Many were chain-driven, and some steered with a rudimentary device called a tiller. Adding to an already rough ride, the wheels were simple metal rims with a hard piece of rubber attached.
The driver was asked to sit on a board, out in the weather, out in the rain, and deal with the elements. Driving an early truck was not a very comfortable experience. I think it's important to recognize that when trucks were first developed, that their focus was to haul freight, not necessarily provide driver comfort. And that's exactly what these vehicles did.
To move freight, trucks needed power, something early gas engines had trouble providing. Railroads, by contrast, possessed more than enough power to continue their decades-long reign as the kings of long-distance transportation. But early gas-powered trucks faced their most immediate competition from trucks propelled by steam or electricity.
When the truck was initially being developed, the very first trucks, it was not a foregone conclusion that they would be gasoline and then later diesel powered. So there were electric trucks and steam trucks, and one of the problems with the early steam vehicles is that they were, built like a locomotive. They had boilers and they required multiple operators sometimes. You had to have a fuel source and you had to keep it full of water or it would explode.
The novel electric trucks were ahead of their time, but were encumbered by large batteries.
Well, the same problems that we've had in the last 20 years trying to develop an exclusively electric car, the electric trucks had mammoth batteries, and recall this is the battery technology of the early 20th century, giant lead batteries with lots of acid. Their upshot was that they were quiet, but for over-the-road use and general use, they just couldn't go very far without having to be recharged.
For many consumers of the era, however, the hard choice wasn't gas or electric. It was car or horse.
Eventually it became very clear that gasoline-powered trucks are cheaper to operate than horses and wagons. You can park a truck for 2 or 3 days, you don't need to feed it, you don't need to watch it, it doesn't get a cold, it doesn't get sick, it doesn't die. It does need repair, but it was just cheaper in the long run than horses and wagons.
Although horse-drawn wagons struggled to compete against gasoline-powered vehicles, the teamsters who drove them weren't going down without a fight.
And one of the ways that the teamsters would try to get a leg up is by backing their wagons with the horses into the radiator of trucks. That was a way to disarm the truck because that was a very delicate part of the truck at the time.
Although heavy, slow, and crude, the fledgling trucks had proven they were here to stay. In years to come, innovators would develop a sleek new fleet of workhorses that would revolutionize the industry. In 1919, a military truck convoy took 62 days to travel from Washington, D.C. to San Francisco because of poor roads and mechanical breakdowns. Trucks will return on Modern Marvels, here on the History Channel. Make room for these earth-moving behemoths that stand more than 2 stories tall. Drivers must scale ladders at the front of the vehicle to reach the cab. Once there, they can literally move mountains. Trucks like these are able to haul 320 tons of earth. Fully loaded, they weigh in at over 1 million pounds. And every ounce of that weight rests solely on the tires. Made of special compounds of rubber and synthetic material, the tires are marvels unto themselves. They stand over 12.5 feet tall and weigh up to 5 tons. Today's trucks, no matter what their size, owe their existence to the tires they ride on. And although modern tires are built to withstand the most punishing road conditions, blowouts are a fact of life, caused either by road debris or excess friction and heat. The best truck tires deliver not only when fully inflated, but also when they're punctured. Case in point, Michelin's new super wide tire.
The construction of the tire is such that when you have a blowout, and we've done this with dynamite on the tires, basically plastic explosive, you can see that it'll just sit right down, the truck will come to a safe stop.
But the most manageable blowout of all is the one you can see coming. Volvo North America's advanced engineering team is working on a new monitoring system that will enable drivers to keep tabs on their tires.
With these devices, we know the pressure in this tire even going down the road. If a driver were to pick up a nail, that's not going to get better, it only gets worse. So the driver is notified in the cab, you have a leak in this tire, but at the same time he's getting that signal, we can broadcast that signal through satellite and go to a service, third-party service or the fleet itself, and say, okay, this driver needs this tire, he's in this truck, we know where he is, we know where he's going.
The advanced system will be a cost-effective time saver, as a new tire can be ready at a predetermined site before the troubled truck suffers a blowout. A century ago, the earliest trucks were equipped with tires that were impervious to blowouts, but had little else going for them.
The first trucks mostly used solid rubber tires. And this was fine as long as the top speeds were limited to about 10 miles an hour, and that was good for city use. If you went out on dirt roads of the country, you had very poor traction with these kinds of tires, no tread or anything.
In the early 19th century, air-filled or pneumatic tires were commonly used on bicycles and early passenger cars, but they were not well suited for early trucks. A truck with solid rubber tires could carry as much as the driver dared to load. But early air-filled tires would explode under too much weight. Even as tire technology advanced, most drivers and owners remained skeptical about the durability of pneumatic tires.
They had a good product, but the public was not convinced because many of the companies that had large trucks and large heavy freight had never had any problems with the solid tire on the rim and the wood spoke. It was just a well-worked horse. So why should they buy these new rubber tires?
Despite their shortcomings, trucks were catching on. At the outset of World War I, the British and French armies contracted American manufacturers such as FWD and White Motors to build trucks for the war effort. Years before the arrival of American troops, U.S. trucks would serve on Europe's battlefields.
These trucks were shipped overseas. Turned out the trucks weren't too good using in the front lines because they were bogged down in the mud of the trenches, but they were wonderful behind the lines for shipping supplies up to the soldiers in the front lines.
Legends were born. The Mack Model AC, with its pug nose and reputation for stubborn reliability, was nicknamed the Bulldog by grateful British troops. The Bulldog nickname would stick and later become the company's trademark. Far from the battlefields of Europe, the American military would soon be putting trucks to the test. In March 1916, U.S. soldiers led by General John J. Pershing crossed the border into Mexico in pursuit of Pancho Villa, who had attacked Columbus, New Mexico. Included in the strike force, 550 trucks. Unfortunately, the U.S. Army had trained neither drivers nor mechanics and was forced to hire civilians. To make matters worse, numerous manufacturers had built the 128 different makes and models in the convoy. Supplying thousands of non-interchangeable parts to keep the trucks moving was almost impossible. Still, Pershing recognized the potential benefit of military trucks.
In 1917, he already had learned a valuable lesson in Mexico, and he immediately went to Washington and to the Bureau of Standards and said, hey, we have to come up with a standardized truck because the problems that we had in Mexico we can't repeat in Europe.
When American troops were deployed in 1917, the U.S. military hastily ordered 100,000 trucks. The government contracted more than 200 companies to build the vehicles. But since the problem of interchangeable parts still hadn't been solved, it was another recipe for disaster. Something had to be done.
The Army called together several of the heavy-duty truck manufacturers and engine manufacturers, transmission suppliers, to come up with a standard truck design that they could all build at the same time and parts would be interchangeable. And this was officially called the standard Type B, but it's generally referred to as the Liberty truck.
World War I was a very significant event as far as the development of the trucking industry is concerned. If we simply look at the numbers, in approximately 1908, there were 4,000 trucks in use in the United States. Before World War I, it had grown to 300,000, and after World War I, it had exploded to over 1 million trucks. The trucks were able to prove themselves to the American public that they were capable of carrying heavy loads under very difficult conditions.
American manufacturers looked to cash in on the truck's newfound acceptance. For the Goodyear Tire Company, this meant finally selling the public on improved pneumatic tires. In 1918, to show the product's superiority, Goodyear outfitted 7 trucks with the new tires and set them loose on America's roads. The pneumatic tires allowed for increased speed and better traction off-road, a crucial improvement as the American road system was poorly developed. The roads that connected cities and states were little more than dirt paths, if they existed at all. Trucks would bounce off the treacherous roads or smash through bridges built to handle horse traffic.
Road conditions and tires are what limited the sizes of the trucks as they grew. I think that truck technology was outrunning ahead of the road conditions in this country.
Still, the trucks were increasing in power and dependability, and the booming post-war economy was ready to put them to work.
So after the war, there was a pent-up demand for goods in the country, a poor transportation system, and thousands and thousands of soldiers coming back with the idea, I'm going to start a truck line.
But one vehicle manufacturer was conspicuously absent. Originally, Henry Ford didn't see the need to build trucks. He was obsessed with mass-producing and selling his Model T automobiles cheaply. Another vehicle line would just interfere. Wagon makers, carpenters, blacksmiths, and even other truck manufacturers made good money converting Ford's Model T cars into extended bed trucks. While some industry giants slumbered, others saw the potential for great profit. In 1900, the Firestone Company, which was competing with arch-rival Goodyear to put tires on American vehicles, began manufacturing in Akron, Ohio. Firestone made a fortune selling tires to Ford and other manufacturers. In 1919, Firestone initiated the Ship by Truck campaign in order to promote long-haul trucking. As trucks began to loosen the railroad's grip on transportation, improved technology gave the growing industry an added boost.
Prior to the 1920s, the engines that were found in trucks were 2 cylinders and 4 cylinders, gas-powered with limited horsepower. With the need to carry heavier loads over improved roads, there was a need to have more powerful engines. We started seeing a movement from 4-cylinder engines to inline 6-cylinder engines, which is pretty much the standard in today's heavy-duty trucks.
The vehicles began to look like modern trucks, with covered cabs for the driver and goods hauled in trailers as opposed to being strapped to the vehicle's body. By 1927, the number of American trucks had grown to nearly 3 million, and demand was increasing daily. Numerous truck manufacturers were there to fill the orders, but the good times were about to end as the Great Depression took its toll on the economy.
When the market crashed and the demand for trucks ceased, most of them weren't in the financial position to weather the storm that followed.
Despite the Depression, however, some truck companies benefited. Public works projects, from road construction to the building of Hoover Dam, depended on powerful trucks to haul tons of earth and equipment. Names like Kenworth, Sterling, and Mack remained strong and continued to keep up with technology. German engineer Rudolf Diesel revolutionized the industry by inventing the efficient engine that still bears his name.
Diesel's idea of using the compression of the engine to cause the explosion of the fuel was the turning point in the development of the so-called diesel internal combustion engine.
Unlike gasoline models, diesel engines don't rely on a spark to ignite the fuel. Instead, the engine compresses the air in the diesel mixture so forcefully that the fuel destabilizes and combusts because of the high compression in the combustion chamber. The blast is much greater than in the gas engine. This means the diesel produces more power, but it also means that all engine pieces must be larger and stronger to withstand the punishment. The greater power output was a boon to the industry, but the heavier-built engines were more expensive to make. It would be years before they became standard equipment. With the outbreak of World War II, dependable manufacturers like Mack and General Motors devoted all their resources to building military trucks. The Army's new workhorse was the 2.5-ton dual-axle, which would move troops and supplies in Europe, Africa, and throughout the Pacific theater. At war's end, North American manufacturers had built 2,600,887 trucks for victory overseas. By the 1950s, a new highway system and a booming economy would lay the groundwork for the golden age of trucking. In 1931, mechanic inventor Plessy L. Cummins drove coast to coast in a truck with a Cummins diesel engine on a mere $11.22 worth of fuel. Trucks will return on Modern Marvels. The open road. Shimmering heat waves rise off endless miles of blacktop. A solitary driver pilots a lonely, austere 18-wheeler. The image of the monotonous life of a trucker is one that today's truck manufacturers would like to make obsolete. The biggest names in the industry are pushing the envelope of design to build trucks with world-class comfort. Today's cockpits are high-tech and luxurious.
This is a 77-inch sleeper, which is one of the largest production sleepers in the industry. This sleeper features a lot of amenities that make this a very comfortable home environment for the driver. Nice upper bunk with an innerspring mattress. The lower bunk also features a workstation, which is a nice area for dining or working at the end of the day. So all in all, the driver has a lot of place to store items, a very comfortable place to stay at night.
While such customized comfort is routine today, in the 1940s, driver comfort was low on the list of the trucking industry's priorities. After World War II, its #1 goal was to meet escalating consumer demand. Trucks began traveling faster and farther than ever before. They could easily handle the flat terrain in the eastern half of the United States. But the mountains in the rugged West were a different story.
The 275 horsepower supercharged Cummins in this 1955 Kenworth was one of the most powerful diesel engines available at the time. On long grades and steep hills, some of the lesser horsepower trucks, 150 and 200 horsepower trucks, you'd practically be counting the lug nuts as they rotated around. You could walk beside the truck. It would crawl up the hill so slowly.
A handful of Western truck manufacturers were trying to bring the West up to speed. The owners of a Utah shipping company named Consolidated Freight figured success hinged on lighter trailers and more space to haul more goods. Unable to find a manufacturer to meet their needs, they decided to build their own vehicles. And the Freightliner Corporation was born. It became a mainstay of West Coast trucking. But such new companies equipped with improving technology could only go so far on America's underdeveloped road system.
The highway system is the partner with trucks in trucking. And early roads were just impassable at times. Mud ruts passed for roads. And if you couldn't get through, the freight couldn't get through. And it's been a gradual process of roads being improved to improve our national transportation system.
In 1956, President Dwight D. Eisenhower signed the Federal Aid Highway Act, which authorized the creation of a 41,000-mile interstate system. Originally designed to accommodate military equipment convoys, the interstate system was ideal for large multi-trailered commercial trucks.
And a lot more thought was put into on-ramps, off-ramps, overpasses, bridges, that sort of thing, just to make sure that trucks could effectively and safely carry their loads.
The golden age of American trucking was in full swing. Better roads and more powerful trucks enabled the industry to deliver almost anything to any location, quickly and affordably. For the first time ever, trucks overtook railroads as the predominant way to ship goods. By the mid-1960s, more than 13 million commercial vehicles were traversing America's roads. Many sported the latest in truck technology, lighter aluminum and fiberglass trailers. But when the 70s arrived, improvements in engine design would take center stage as the world's fuel supplies were threatened. Most 18-wheelers today have 12 gears, 10 forward and 2 reverse. Trucks will return on Modern Marvels. They are the kings of the road, commanding 40 tons of machinery, moving at 70 miles per hour along endless ribbons of asphalt. But even the best drivers are vulnerable to the hazards of the open road. Perhaps no company recognizes the inevitability of traffic mishaps more than Volvo. It's built its reputation building safe, reliable vehicles, including trucks. At Volvo's Safety Testing Center in Sweden, engineers orchestrate a symphony of sudden impacts in the name of safety. They crash vehicles into fixed objects to judge driver survivability and learn how to improve overall truck design.
One of the driver's concerns that we have to address is what happens with that engine that's directly in front of you in an accident. So we've designed that engine to move down and underneath the cab, thereby allowing the driver to safely exit the vehicle when the accident is completed.
Today, 50% of truck driver fatalities in the U.S. involve a rollover crash. To test a cab's integrity, technicians slam 1 metric ton weights into window support columns in the rear of the cab to simulate the crushing forces exerted during an accident. The tests have yielded better cab design and construction. The knowledge gained in thorough research and testing has paid off and lives saved. Truck driver fatality rates have dropped roughly 50% over the last 20 years. But truck safety is as much about preventing accidents as surviving them. Anti-lock brake systems, or ABS, have improved with the addition of computer monitoring, helping to bring multi-ton vehicles to a stop quickly and safely.
When you think about the size of a tractor trailer, you don't realize sometimes that the most critical part of that tractor is this right here, where it hits the road. And that's where braking comes in. You might be surprised to realize just how fast these trucks can actually stop. They have a very advanced braking system. The Volvo features ABS with traction control. We also have a new innovation for vehicle stability. This system works with the ABS system and traction control and looks at situations where the driver might be approaching an unsafe event. There are sensors in the vehicle that see what's happening, as well as looking at what the driver is doing with the steering wheel, the throttle, and the brake. And if needed, will apply more braking, take throttle away, so that the driver can continue that maneuver safely.
The quest to make safer trucks has been an ongoing process. In the 1960s, engineers devised what came to be called the Jake brake. The Jake brake uses the truck's own engine to slow the truck down to a controlled speed while going downhill. Normally, the pistons inside the engine work to compress air and fuel, which causes an explosion that powers the vehicle. The Jake brake slows the engine by opening the exhaust valve, allowing the compressed air to escape. During the 1970s, engineers made additional strides in safety as they applied ergonomics to cab design. They modified seats, steering wheels, and instrument panels to increase driver comfort and decrease driver fatigue. But the fuel shortages of the 70s caused the most significant change of the era. fuel efficiency became the #1 priority. One solution was aerodynamic truck design. Curved edges and spoilers became standard design features. Engine manufacturers also felt the crunch. In 1985, after nearly a decade of research and design, Detroit Diesel introduced the first electronically controlled diesel engine.
Electronics really started a revolution in the configuration of our trucks. Back in the late 80s, the U.S. government had proposed more stringent emissions requirements for heavy-duty diesel engines. And the only effective way to be able to meet those regulations was the addition of electronics to control the fuel system and in essence, control the operation of our engines.
Today's electronically controlled fuel-efficient engines use massive amounts of torque and horsepower to pull loads up to 80,000 pounds.
This 16-liter engine puts out 625 horsepower and 2,250 foot-pounds of torque. And torque is what gets something moving off the line. It gets the load moving to highway speed. It also allows the truck to maintain that speed going up a grade. And maintaining that speed is what allows the driver to get the load to the destination quicker.
Although the most important advances in truck design are crowded under the hood, other innovations strut their stuff proudly in the open.
The Volvo VT880 really brings together a blend of aerodynamics. For example, you see that in the headlamp assembly, which is designed to keep air moving very smoothly over the surface. But it also brings in that beefy, muscular look that owner-operators want, the large forward hood. So it's a very effective blend to give the look and still provide maximum aerodynamics. Aerodynamics means fuel economy. Fuel economy means profitability.
The profitable multi-billion-dollar truck industry is banking on computer-controlled collision avoidance systems and driverless technology to help pave the way to the truck of the future. Today's short-haul truck drivers lose valuable time, waiting an average of 33 hours a week while their cargo is loaded and unloaded. Trucks will return on Modern Marvels. As the strength, speed, and safety of trucks have developed, our dependence upon them has grown. Modern life revolves around a steady stream of goods and raw materials being delivered on time around the globe. Keeping track of the millions of trucks on our highways has become a vital necessity. San Diego-based Qualcomm tracks over 335,000 trucks worldwide and receives millions of messages and position reports every day. The Network Management Center receives the messages, along with the truck's location, via global positioning satellites. The truck's delivery time, location, and driver's messages are then relayed to the truck company, helping to avoid traffic congestion and decrease loading and unloading time. In its ongoing effort to maximize efficiency, the industry has pioneered several innovations in truck maintenance. Numerous onboard sensors monitor the truck's engine, brakes, suspension, and other vital components.
We can take that type of information and through satellite or cellular communications, feed that information from the truck back to the maintenance repair manager back at the home base. So long before the truck and the driver are stranded along the road, we have the capability to be able to forecast that in the next weeks, the next month, a particular system or a particular part is going to need service or it's going to need repair.
So what's next in advanced truck design? Volvo is testing new technologies using this vehicle as a rolling research lab.
The Advanced Engineering Department within Volvo builds these things for the purpose of evaluating technologies and getting customer feedback as to whether a particular technology is worth pursuing to take to production or not.
Researchers and technicians are currently testing a computerized wireless communication system that may save freight truckers from time-consuming inspection stops.
The purpose is this truck will inspect itself with electronic sensors, and then as we approach a weigh station, as a for instance, then this truck will tell the weigh station, I'm okay. And the weigh station will say, this truck's okay, gets a green light, the trucker goes right on past without having to stop. There's 2-some million inspections every year, and this truck that will inspect itself and broadcast that inspection.
As new generations of trucks inspect themselves, they'll also be able to help their drivers inspect what often eludes their view.
In any truck this size, there is an area that's commonly called the blind spot. That blind spot is a dangerous place for a small vehicle, such as a small passenger car, to drive because the driver cannot see him. So in an attempt to try to get visibility of that blind spot, we've added this camera here. If I turn on my right turn signal, there's our audio man. I can't see him from where I'm sitting, but I can see him very clearly from that blind spot camera.
Forward-facing radar is another tool commonly used today to help truck drivers avoid collisions. If your reaction time's been slowed by a full day on the road, it'll help you steer clear of slow-moving cars or those making erratic lane changes.
The Doppler radar, similar to what your local weatherman may show, senses speed rather than just the image. If a vehicle pulls directly in front of the truck, this allows the computer then to calculate what is the safe following distance. The vehicle will automatically slow down to maintain that safe following distance. Once that traffic clears, the vehicle will resume the previous set speed.
Modern technology has made the driver's job safer and easier. But trucks of the future may take the driver right out of the equation. These two prototype vehicles are being developed by Daimler Chrysler. The first truck is operated conventionally. The second is electronically linked to the first. In this high-tech version of Follow the Leader, an infrared camera in the second truck tracks a target painted on the back of the first vehicle. The second vehicle drives itself with the information provided by the lead truck. In recent years, the Pentagon has been developing its own driverless vehicles with one goal in mind: saving lives. Historically, slow-moving military supply convoys have proven to be among an army's most vulnerable targets. Today's strategists hope that unmanned trucks will one day relieve soldiers of this hazardous duty. Oshkosh's Terramax is a thinking machine that gives new meaning to the term military intelligence. Equipped with an autonomous guidance system, the Terramax can identify obstacles, then decide whether to go around or over them, and at what speed, all without any human input. State-of-the-art unmanned vehicles are truly the trucks of the future. In today's electronic, fast-paced society, trucks might seem like old-world technology. But their ability to handle almost any load and deliver goods almost anywhere makes them an integral part of modern life.
And that means we'll always have a need for smarter, more capable, more fuel-efficient trucks and smarter, more capable drivers. We will see this continue into the future, that marrying of technology and skill and beauty to bring your goods to your door.
Our love affair with the world's